Okay. Well, I think people are sort of slowly joining us here today. So I'm, in the interest of time, I am going to just start off by welcoming you all to this, what is a very important seminar for us. This is the almost the accumulation of an activity that's been going for 2.5, 3 years now, to help chart a roadmap to ultra low energy resilient building. I'm sure many of you who are attending have actually been involved in some of the review, and would like to thank everybody who's taken the time to look at this. It's a very novel approach to what is a very complex problem. So we're going to have so we've got oops. My name is Robert Krolhold. For those who don't know me, I'm Executive Director of the Canadian Academy of Engineering, and have been participating in aspects of this presentation as things move along, not as much as I would like to. But the four principal authors are Andrew Pape Salmon, Andreas Athianitis, Rosamund Hyde, and Chris Kennedy. And they may just say a quick word about their affiliations. Most of them, with the exception of Rosie, are fellows of the Academy, and we've been hugely appreciative for the time and effort that Rosie's put in as sort of as somebody who's associated with the project but is not actually of the Academy. And that kind of input is very important to us getting a balanced view of these topics. So the way we're going to go through today is I will pass the chair to Andrew for now, and he will start I guess with the introduction, unless you want me to jump straight to Andreas, Andrew. But if you want to say a few words at the beginning, I will let you do that, and we will get going. Now I'll come back. I'll be timekeeping so that we'll have time for questions as we go along, and we'll be back with you at the end for a wrap up. And it's very important for us in this session to actually get feedback, your thoughts and opinions. You'll notice at the bottom of your screen there is a Q&A panel. So if you have questions, please use that panel to ask them. We're in a webinar format, so you can't actually do it through chat or video. So the Q&A is the way to ask questions, and we'll make sure that the questions are answered to the extent possible by the panelists. Andrew, please.
Great, thank you, Robert. And I will pass it over to Andreas momentarily. I'm based in the traditional territories of the Lekwungen-speaking Indigenous peoples and the Songhees, Esquimalt, and WSÁNEĆ First Nations. And what is this roadmap to resilient, ultra-low energy buildings with deep integration of renewables? Fundamentally, it's at a 10,000-foot level to provide guidance to key influencers and decision makers to achieve resilient decarbonization of buildings specifically. Our goal is to provide a compelling and achievable vision for resilient and decarbonized building stock in Canada, and metrics of beneficial outcomes aligned with the vision. So this can be evidence-based and measurable, and based on case studies of actual achievements in Canada that Andreas will speak to. And what I'll speak to is policy principles to inform public policy. We're not going to provide a particular policy solution. Rather, what are the principles that policymakers can contemplate and apply when developing policy, because it is our goal to be non-political, so that all political stripes can feel that this roadmap is compelling. And then we'll close with a call to action for the engineering profession to establish a building innovation ecosystem to catalyze the transformation. So the history started around 2018, actually at the Pacific Northwest Economic Region Conference in Whistler. This idea for a roadmap came up, and in parallel, I began speaking with Andreas and others about creating a roadmap for engineers across Canada, starting with a communiqué, which is like a 2-page summary of what are some of the barriers. And we established those. We had a workshop in Montreal hosted at Concordia, and then a second symposium during the pandemic virtually, where we received papers. And I described that 2020 as the energy efficiency event of the year. And I'm sure Andreas will speak more about the 2020 symposium and communiqué, followed by a workshop on resilient communities, again, virtual in 2021, and then a face-to-face meeting in Calgary with the Pacific Northwest Economic Region, a panel discussion entitled Bridging Silos to Catalyze Decarbonization and Resilience of Buildings. I'm going to pass it over to my colleague, Andreas, to carry it from here.
Thank you, Andrew. It has been a great pleasure working with the Academy and Andrew himself, co-chairing this roadmap at the beginning. He had to step back for a while, but I think now he's come back with a lot of activity concentrated at UVic. So Concordia and UVic are two universities which are very strong in this sustainability area and zero carbon buildings and communities. So I was very pleased to work with Andrew and also with Chris. We have been working with UVic, with Chris especially, through 2NSERC strategic networks. So we had a big network, and the roadmap attracted a lot of interest and a lot of input from the different user sectors, the municipalities, government labs, the industry, and so on. So this is a very important exercise that is taking some time, but with a lot of activities, a lot of content. So I'm very pleased to see how it's coming and all the influence it has. And so I'll talk about the case studies now. Okay. So the three case studies are novel and high-performing community-scale or building projects in Alberta, Ontario, and Quebec. And either we have been involved or our partners in all of these projects through federally funded programs, the 2NSERC strategic networks on smart net zero, solar buildings and communities. Graduate students were involved in all three. So they were easy to follow. And I'll be talking about the details of each case study next, okay? Next. Okay. So the Drake Landing Solar Community project in Alberta is the one that started earlier and emphasized long-term thermal storage with geothermal boreholes. So when we say long-term, just to give you an example, this takes 5 years to reach steady state, but it's performing very well. It provides nearly 100% solar fraction for heating, and it includes 52 homes with solar collectors on the roofs as well, but that's for the domestic hot water. Okay. And now more details. As you see, we have an intermediate energy storage, the energy center, which connects the houses to the long-term seasonal storage. one of the lessons learned is that to make this more cost effective, we need to go bigger scale. For example, make it for 300 houses and integrate also a lot of the urban planning and the density aspects with the design of the energy system. So for example, having a mixed development with higher density could lead to better outcomes. Okay, we'll go to the next one now. So the West 5 Sustainable Community in London, Ontario is one where we use some of the lessons learned from the Drake Landing project. So this one is an ongoing project and it's only partly completed now. You see some pictures there from the buildings that have already been built. So what's a big element of this community project? It has PV on the roofs and facades of a lot of the buildings. It has integrated electric vehicles. A major innovation is in the microgrid business model. So this is a case where the developers, in this case in London, Ontario, worked very well with one of the partners in our NSEC strategic network, S2E, to develop this project, which is ongoing, as I mentioned, and a major contribution to the developments and innovations in this area. And I would say both projects, both the Drake Landing and this one, are innovative on a world scale. So we do have very strong research in these areas in Canada, and they are good examples of efficient integration of the different renewable energy technologies together with the energy systems and controls and so on. Okay. Here you see some of the more detailed pictures of the development. On the top right, you can see a higher density development, a bit higher density than the one in Drake Landing. Here we don't have seasonal storage. As I mentioned, we have heat pumps, we have PV, energy efficiency, and this is an electrified community with integration of electric vehicles. This is very important. So there is a separate micro utility company, another major innovation on the business side that came out of this project. And something which we talk very often with Andrew and Chris is about how we can overcome regulatory barriers between the various levels of the government, municipal, provincial, federal. It's quite a complex task. So now here is something that I have to give credit to my colleague, Dr. Caroline Cashen-Vermette, who was a graduate student who worked on this project together with Milfred Hammerbacher, the CEO of S2E. And these are some of her preliminary drawings that influenced the whole design of the community. And she studied different alternatives where some of the buildings could be net positive, some of them net negative, but overall the community is net positive. So it's a real net zero project. And again, a major achievement in Canada. It's ongoing. And in fact, we have a meeting with this group at Concordia, I believe in 2 weeks, to discuss further developments based on the lessons learned. And Caroline was an associate professor in Calgary, but we managed to get her back to Concordia recently. So she's an associate professor in our center and contributing to this area in a very important way with other colleagues like Ursula Eicher, who is a Canada Excellence Research Chair, and so on. Okay, now the last project I'm going to talk about is a net zero energy building, a very ambitious project, the Varel Library in Quebec, in the Montreal metropolitan area, the greater Montreal area. And here the concept right from the beginning was to make this a very ambitious project where we integrated the energy generation technologies, the passive solar design, the energy efficiency, geothermal systems, and also to have the capability for electric vehicle charging. What you can see there is actually my Chevy Volt getting charged. And if we compare this building with a typical institutional building of the same category, it consumes only a quarter of the energy. So whereas a typical institutional building will consume between 250 to 300 kilowatt hours per meter square of floor area per year, this only consumes 70. Okay, so energy efficiency is very important, and it's the base of what we're doing. And then comes the energy generation. So why put the PV on the building? It's obvious, we don't need more land, so we save a lot, and we can even use a parking lot for more PV to generate more energy. So one of the things that is promising now, in which we are studying, is how to use a building like this as part of a microgrid to provide heat or electricity to nearby buildings in a neighborhood. And we're following its operation, especially on the topic of model predictive control and developing energy flexibility that will help the grid to reduce its peak demand under an ENSER Hydro-Québec industrial chair that I hold. There is also a related ASHRAE publication listed there with lessons learned. So, so basically, we know we can do this. And would you say this is the best we can do? Probably not. We can do a lot better, both in the energy generation, in the controls, and the integration with the grid. So especially in Quebec, we have this problem of high peak winter demand during cold days. When it goes under -20, this happens a lot some years. In this year, it didn't happen too much. Last year, we had 3 weeks with -20s. So reducing the electricity demand from buildings, and most buildings in Quebec, especially residential, are electrically heated, is very important. And this can be done through use of predictive control with heat pumps and preheating the building outside the peak periods of the grid, possibly using electric vehicles as storage devices to shuffle electricity between the car and the building and the grid, as it is advantageous. In fact, Hydro-Québec is introducing dynamic tariffs to motivate this approach. And I expect this to be also very important for BC as well, another province where a lot of electricity is used. But a lot of the lessons learned apply to other provinces. So this is a case study under 2 IEA tasks, one on energy flexibility and another one dealing with data-driven smart buildings, again emphasizing smart buildings and optimizing operation online and grid interaction. ASHRAE, by the way, is very interested in this topic, and a lot of us are very involved in ASHRAE. I'm a fellow of ASHRAE and still sending a lot of students to the conferences there. And that's one thing we need to do in Canada, basically use our ASHRAE linkages to develop this area further, but also to give us more influence internationally, and also to apply this in Canada. So basically, we have the elements of excellence in Canada on the research side and on the application side. Now, a big question is how do we make this more widespread, more cost-effective? So the business aspect is very important. The business case, for example, the PV on a building like this, if it helps the grid to reduce the peaks in combination with thermal mass heat pumps and battery storage or linked EVs, then it will get some reward in terms of dynamic tariffs. So the business case becomes more complex when we put the complete picture. So I would like to stop now and take some questions. Okay, final slide. Yeah, let me quickly go through this slide. You see a bit on the grid interaction. So the connected technologies, the EV, the ground source heat pump, the thermal storage in the floor, And then a graph on the right showing the net consumption, the net production. The scheme under which this building is connected to the grid is that it can provide up to 50 kilowatts to the grid. So even in the middle of the winter, the building can provide more than 50 kilowatts. And so some of the energy is given free. It's the bottom part of the graph, the shaded brown. So basically, this is a net zero building easily. And we're still studying it. So it's a research project in progress with continuous lessons learned. And more research needs to be done to optimize such buildings and their operation. So thank you, everyone. So I'll take questions now.
Yeah, thank you so much, Andreas. Three really interesting examples. So I will remind people online, in order to ask questions, if you go to the Q&A button at the bottom, and then you can type in your questions, and I will read them out. I will just start with one of my own, Andreas. I mean, there is a lot of technology wrapped up in the three examples that you have shown. How do you find the information coming from these case studies is affecting building across the country? And just to say, the total greenhouse gas footprint in Canada to do with building, heating, air conditioning, hot water is almost 20% of the total, but it's distributed across so many different stakeholders. So maybe just a few words on how the knowledge that we're gaining through these case studies is as we're trying to build 1 million new houses in Ontario and all of the other initiatives across the country. How is that knowledge transfer going?
Thanks, Robert, for the question. And by the way, I want to thank Robert. He's contributing a lot to this roadmap, although he took it on after Midway. And the knowledge transfer and the whole examples and lessons learned are equally important with the work that was done, or even more important. So that's something where the academy can help a lot also, as well as government organizations like NRC and CanMet, NRCan. So we haven't done as well as I was hoping in the knowledge transfer. They have an important impact because these are three important case studies, not only for our Center at Concordia, they're important for NRCan, they are important for the government. So we need to do better in terms of knowledge transfer and lessons learned. And obviously one way is through the universities, because professors tend to stay a long time. And you see some of these case studies take more than 10 years. The development in London, Ontario is not finished. I think now it's finished about 25%. It's basically a mixed use community for between 10 to 20,000 people. So it started around 2005, 2006, and it's still ongoing and only 25% completed, simply because developments take a long time to develop, especially when you are building a whole new town in this case. And you need universities to stay connected, and you need the government labs to work together with the universities. We need the FCM to be part of this whole consortium, and we need to keep doing these things and doing more.
Okay, well, thank you so much for that. So I'm having not seen any questions, and I do encourage people, I mean, even if the question occurs to you further down the line, please type it into the Q&A section, and it will be good to get a dialogue going as we progress. So I would next like to introduce Dr. Chris Kennedy from University of Victoria. Chris, if you can take up where Andreas has left off, and look forward to hearing your part.
Yeah, thank you, Robert. Yes, I can do that. And First of all, let me just say it's been a pleasure working with old colleagues, Andreas, Andrew, and Rosie, and Robert yourself over the last few years on this. I think Andreas has demonstrated that there's a lot of good, promising, proven Canadian technology that can help decarbonize and help us make resilient buildings. I'm going to sort of go up to a slightly higher level and also pull a little bit from sort of international best practice or best in my few words. Okay. So essentially, we see this roadmap as fitting in a vision that sees Canada completely transforming its energy systems in order to both adapt to climate change and mitigate greenhouse gas emissions. And in addition to everything else that the design of our buildings, transportation systems, and industry already achieves, we need to add this additional emphasis on eliminating the use of fossil fuels, substantially increasing energy efficiency, and also bolstering resilience. Now, the elimination of fossil fuels obviously is to reduce emissions, but some of the technological approaches, and it's really very well demonstrated by the library example that Andreas just gave, mean that we really need to reduce our energy demand substantially. Otherwise, the new energy systems would have to be so much bigger. And bolstering resilience is very much about adapting to climate change, but it also comes in my part of the world over here with Andrew is about resilience to earthquakes and other shocks. Okay. So in terms of the decarbonization, what I'm showing in this graph is a comparison between Canada's end-use energy for the building sector, so that's all types of buildings, commercial, residential, industrial buildings, expressed in gigajoules per capita. And we're comparing Canada against two world leaders, Norway and Sweden, who really for decades have been out in front, not just of Canada, but many other parts of the world in terms of dealing with climate change. And they have somewhat similar climates to some Canadian provinces. There are other Canadian provinces that are, you could argue are a bit colder. But the reason why I'm showing this is because this vision of a very low carbon future is already being achieved. And so we're not talking about some technological pipe dream here. You can see in this graph here that fossil fuel use for all building needs in Norway and Sweden is about 5% of total end use energy. Whereas in Canada, it's more like, sort of 40–50%. Canada uses 17 times more gigajoules per capita in buildings than Canada does. Norway uses 11 times more fossil fuels per capita than Canada does. So they're really standout leaders. In the Norwegian case, you can see that the strategy is really one of electrification. You see the green bar there. They're using more electricity per capita than Canada is. That obviously they've got a lot of hydropower and they're using it to run heat pumps. In the Swedish case, there's also a lot of use of heat pumps as well. We've had some exchanges on that over the last couple of months. But biofuels, use of biofuels and waste. So using the forest resources to produce biomass, which then goes into district heating systems, for example, is a major activity in Sweden, as is reuse of waste. They actually import waste from other parts of Europe. So with those two strategies, you've got sort of these two alternatives, and you can do both of them to drastically reduce your use of fossil fuels in buildings for all different purposes. Okay. I want to make sure we don't lose this emphasis on resilience. So in this vision, because it's really, really important. And we've got experience here. Those of us that are old enough, including me, we've got experience of the ice storm in Quebec, which was what, 15, 20 years ago now. And also more recent, we've got the forest fires in California. This is actually from 4 or 5 years ago, where in both cases you had hydro lines that were taken out by the shock. And the reason for bringing this up is that if Canada goes down the heavily 100% the Norwegian strategy of electrifying everything, which is something that is not a bad idea, but if you only do it from sort of provincial scale grids, you're actually setting up our buildings to be less resilient than they are now. Because if you are 100% dependent on electricity from provincial grids, then when those grids go down from climate change shocks or other shocks, then we've got a serious problem. So the vision has to include generation of energy at the building and community scale, which again puts us back to buildings and says, why are buildings so important? Why is that library so important, generating PV off the roof? So a diversity of carbon-free sources. It also means that, you know, looking at non-biogenic sources of carbon, for example, is also important at that building scale. So next. My work, or my contribution to the roadmap, was also included some sort of looking at the markets for green building standards, or the progress of the green building standards. So this is a market update, although I need to clarify that this was work done a year ago. So we're actually, it's not quite today's market update. It's as of May 2022. I reached out to a number of organizations, some in Canada, some elsewhere, just to say, well, how are you doing in terms of your net zero energy or net zero carbon standards? So you can see here on the left, the first figure shows the Canadian Green Building Council, which as of 2021 had close to 700,000 square meters of registered space, and of which 500,000 square meters had actually been certified as that, in this case, zero carbon. And that's a fairly I would say that it's obviously a Canadian standard, and it's a fairly popular standard because it's from the Canadian Green Building Council. On the right, I've got some data from the Canadian Home Builders Association, and they have a net zero energy and net zero energy ready program, which they really bumped up in 2018. And you can see that as of 2020 and 2021, they had between 200 and 250 units constructed. Now, this isn't necessarily zero carbon, but getting to net zero energy helps an awful lot. About a quarter of these units are actually net zero energy, and the others just basically need the PV to be added on the roof in order to make them net zero energy. That's the difference. Okay. In this search, I also reached out to the International Living Futures Institute, which is US based out of Seattle. It's really the gold standard in zero carbon certification. Like the Canadian Green Building Council, they're actually looking at performance-based measures, not just design-based measures, which is really important in this area. As of a year ago, they had 46,000 square meters of certified zero carbon buildings, and that includes the embodied materials and other features. So it's a slightly higher bar in terms of zero carbon than the Canadian Green Building Council. The actual number of projects in the works was about 50 times bigger than that, so over 1 million square meters they were working on. I also got some data from the Passive House Institute, which is again international. And again, Passive House isn't necessarily shooting for zero carbon, but it shows that there's a lot of highly skilled building builders, who can build really tight envelopes and do more complicated stuff than your standard building. There's over 3 million square meters of Passive House buildings globally. And so this just demonstrates that there's a really good growth on the ground of the industry, building the type of buildings that we are trying to achieve through our vision. Next. And just one last slide, and again, apologies that it's not a Canadian example, but just to go back and not forget this resilient attribute. This was a newspaper article that caught my eye just about 6 months, maybe a year, slightly more ago. It was a solar-powered town in Florida called Babcock Ranch with 2,000 homes, and it had just survived completely intact Hurricane Ian, and it's designed to withstand hurricanes. So it's designed to withstand flooding. All the cables are buried. The 700,000 panels are tightly fixed so that the wind doesn't blow them off. And again, it emphasizes this point that you can build solar communities to be really, really highly resilient. And that's another important part of this vision. So next. That is my last slide, actually. So I'm open to questions. I see there's actually a couple there. Robert, are you going to manage these Or-
Yes, no, I will manage these. What I did just want to say quickly to Harshan was and to everybody, both the slides and the video of this session will be available from on our website within the next couple of days. You know, I think Heather asked the question actually relative to Andreas's presentation, but I think it holds just as importantly for yours, which is, you know, what, having looked at Norway, Sweden, and a number of other places, what do you think would be the biggest improvements that Canada can make in order to move towards that both resilient and low carbon future?
Well, I actually think that our building codes should have electricity storage and PVs on buildings as part of them. And I don't actually know the best route to get there. I did some work with Andrew when we were looking at the sort of the role of the energy regulator, the role of the local government, the role of provincial governments and the national building codes. And it's a bit of a tussle as to who's really responsible for, you know, there's a jurisdictional problem there. But I do think that is really important, that we store energy at the building scale or the community scale. And I think the battery is one way of doing it. There are other ways, but storing electricity in particular is really key. I think that's the most important thing we should work on.
Okay, no, that's really important. And I think the building industry can be quite conservative and is very price sensitive. And so when you start adding things to the price, and I don't know whether we didn't get a chance to talk about this before, so I don't know whether you would have an answer, but certainly I know when Andrew and Andreas were presenting to the Ontario Public Works Commissioners, one of the comments that came back had to do with the price premiums that in order to make these ideas attractive to either public or private builders, the premium that you pay over existing cost and which obviously gets passed on to to the customers, consumers, is probably one of the other big challenges. So do you have a sense of what the premiums are on building costs per square meter or building, and how rapidly they might come down?
I don't off the top of my head. I might have seen it a few years ago. I'm happy for another colleague to step in if they wanted to.
I have an estimate. I can give an estimate based on my house where I did a few things. The premium will not be for a typical house. You can easily get it to net zero with about $20,000 at most, provided you do the energy efficiency, good levels of insulation, and so on. And if you have an electric car that can be used in bi-directional electricity flow, then it actually becomes very cost effective.
Okay, thank you, Andreas. That's a very good example. I did just want, I see that John Leggett's asking a question here around hydrogen, and we are hearing a lot about the opportunities for the hydrogen economy, both so-called blue hydrogen that is comes from the natural gas along with carbon capture and storage, as well as green hydrogen coming from electrolysis. It's early days in the hydrogen industry, so Chris, I don't know if you've seen much out there in terms of the actual application for hydrogen.
I remember reading a book 30 years ago that said hydrogen was 15 years away. Right? And there's a book 15 years before that says hydrogen 15 years away. No, I'm being a bit facetious. I think it's really important that in Canada, we do give opportunities for the hydrogen economy to grow. And we do give opportunities for renewable gas, for example, to play a role. but we don't stake everything on them. And we actually have to make them get their act together a bit faster. I think there's a problem. It's actually deep and cultural in Canada, where we're kind of waiting. We're trying to continue business as usual and say, oh, we've got this hydrogen and we've got this natural gas, and it's stopping us from doing something that the Scandinavians did 20 years ago, which is decarbonize. It's actually it's possibly a problem, and it's an excuse. It's a bad excuse.
I will say, just touching on John's question, there's a general consensus that you can add 15% of hydrogen to the natural gas stream without upsetting things too much. And it did have me recall, which I've probably mentioned within the panel before, that back when I was a child, which was a very long time ago, in the UK, and my grandmother was looking after me, they did the changeover from coal gas to North Sea gas, which was effectively a changeover from a gas mixture that was 50% hydrogen to one that was 97% methane. And one of the effects of that, which I remember to this day, was that they had to go house by house and change all of the burners. I have no idea what happened with leakage, with hydrogen embrittlement, or anything else that could have turned up. But I do remember her being very upset that the eggs just didn't come out the same way over methane as they did over hydrogen. So
I remember that too, Robert. I was a child living in Scotland when that happened. 1970s. We were still under a Keynesian economy.
So just to say, for people who are considering, who sort of say, wow, is hydrogen in the house is a weird thing, we've been there before. It wasn't 100%, it was 50%. But it's not just a question of turning on the tap. And we're living in a very much more sophisticated energy distribution system than we were in the late 60s and early 70s. So let me just
I'm happy to comment on hydrogen as well. There's the two pilot projects, one in Markham, Ontario, and one in Atco in near Edmonton in Alberta. 5% blend, 2% blend. I think clearly hydrogen that's incorporated into the methane pipeline is one method of decarbonization. I think dedicated hydrogen pipelines, which do exist today for refineries and the upstream oil and gas sector, hold a lot of promise as well for larger loads, and including possibly for peaking power plants. Hydrogen has an inherent advantage in that it produces zero Scope 1 emissions, whereas methane has Scope 1 emissions that are displaced by reduction of Scope 3. So Scope 1 is the emissions that occur in the building. Scope 2 emissions are the emissions that occur in the energy distribution system. And Scope 3 emissions are those emissions in the broader geography and the economy that can be reduced to offset Scope 1 emissions. And hydrogen has that inherent advantage. So the jury's out. The good news is that we have a competitive marketplace between fuels, despite having natural monopolies serving electricity, gas distribution, district energy. Those are natural monopolies, but fuel choice is a competitive marketplace, and the winner will prevail. Here in British Columbia, we have a hydrogen gas station that's just been opened in Prince George. They fuel trucks. They use electrolysis. A lot of people are saying electrolysis is expensive. There's technology to convert methane or natural gas to hydrogen and capture all of the carbon. Again, the jury's out on what method of hydrogen production will be the winner, but there's a lot of emphasis on that right now. I wonder, Robert, if we should move into the next piece. There's a lot of good questions here, but in the interest of time, should we answer some of these later? Okay, you're muted. And in fact, I could actually, as I'm talking, I'll answer Richard's. I hope I answered Camille's and John's question. I'm going to invite later. I'll invite Chris to answer Paul's. Back to you, Robert.
Yeah, sorry about that. So yeah, I think let's move along and come back to some of these questions at the end. But I think to hydrogen, your answer that market forces are at play on hydrogen is certainly, in the view of many of the people in the academy, is really the answer. It's going to be very regional for the foreseeable future, and in areas where hydrogen is being produced, we will see how it cost effectively can be integrated into the heating system the same way as the transportation system and the industrial systems. So with that, let's move on, and Andrew, you're going to talk in some ways where this leads us in terms of the policy principles that we're putting forward. So thank you.
Thank you. I'd like to pick up on both Andreas and Chris's comments about institutions and regulation and barriers. And fundamentally, public policy has a big impact. So keep in mind, public policy, which leads to regulations, it really leads to taxes and tax policy. It leads to investment in R&D, investment in public sector organizations. It has a big impact. The single largest land owner of buildings in Canada is the federal government. So what the federal government decides to do through their procurement for their buildings, especially as we build out, our NORAD commitments, and that's more around early warning and things like that. But there are buildings involved. That investment in zero carbon standards by 2025 is going to have a big impact. So public policy is powerful. Now, the building sector is one of the most heavily regulated sectors of the economy. I challenge somebody to identify another sector that's more regulated than maybe healthcare, because we have a single payer. But when you think about sectors of the economy, the building sector is one of the most heavily regulated. And just look at the boxes in front of us. These are all the regulations that exist today and may exist in the future. The x-axis is what I'm trying to show is the impact of these boxes, which are the types of government measures or regulations that are trying to influence the carbon emissions from buildings. The x-axis talks about the total, what proportion of the total emissions of the total, the x-axis is the proportion of an individual building's emissions that are affected by the various measures. The y-axis, the vertical axis, is what proportion of buildings do these measures or regulations or policies impact. And so the top right quadrant measures are the ones that have the largest benefits. They affect a large proportion of the building stock, which is the vertical axis, and they affect a large proportion of the total emissions from individual buildings, which is the horizontal. Now, the problem is, wouldn't it be great if we could just focus on the top right quadrant and get the job done? Well, we live in a pluralistic society. We have a democracy. We have a free marketplace. And so in order to achieve those three boxes on the top right, including building codes, which is slightly below the top right there, which affects only new construction, we need to show that the market is ready. Otherwise there will be political pushback to incorporating or introducing regulations, and it's part of the what I call the market transformation cycle. So we need to introduce the concepts voluntarily so that buildings like the Varennes Public Library and the London, Ontario, and the Alberta community, Drake Landing, they show that it can be done. So those are demonstration projects. They help develop new standards. So we've got a standard approach across Canada on how we do this work, so that there's acceptance in the development community, and so that it's affordable and achievable. So that's what all the other boxes try to do. Now, one thing that's working in favor of a harmonized approach or an orderly transition to decarbonization for buildings that supports market transformation is through the Canadian Free Trade Agreement. And it's called the Reconciliation Agreement on Construction Codes. And it took effect earlier this year, last year in 2022. This Reconciliation Agreement on Construction Codes has been endorsed and signed by 14 ministers across Canada, provinces, territories, and the federal government. It commits provinces and territories to work within the National Building Code system to advance future codes, culminating in the 2025 National Building Code of Canada. And this means that codes and standards that are unique to individual provinces and territories will largely cease to exist by that time. It forces consolidation and collaboration among key influencers. And why is that important? Because that will also, if we have a single approach to building codes and standards across Canada, that will start to show up in the voluntary standards like the Canada Green Building Council. It will start to show up in the Canadian Electrical Code. And the answer, by the way, to the first question of discussion was, how can we do this? How can we introduce storage in buildings? Well, it needs to be both the building code and the electrical code. Right now, the electrical code has a bunch of standards as it relates to EV charging, and it supports electrical safety. So having a single approach across Canada will allow for all the other codes and standards and all these boxes to become harmonized. Now, I do want to point out something really important, and that is that and I'm going to move to the next slide, that the latest edition of the National Building Code of Canada, which was published about a year ago now, it's the 2020 National Building Code, 2020 National Energy Code for Buildings. It has something called a tiered energy code. So there's 5 steps for energy efficiency in the National Building Code. So for example, we're all singing from the same song sheet. British Columbia might adopt, a certain mid-level step or even a higher step, and another province may adopt a slightly lower step to reflect the level of market transformation in their individual jurisdiction. So those are what I call leadership codes or tiered codes, which you see in the very bottom right, which right now are adopted by individual municipalities. Where I live here in Saanich, British Columbia, the local government has committed to net zero energy ready codes almost immediately, and zero carbon codes by around 2024. So 1 year from now, we're going to see here in Saanich that every building will be similar to those 3 case studies. So here are some other policy principles. Let's bust down some silos of, here's a public utility regulation, here's the building regulatory system, here's the electrical safety regulatory system, here's the local government planning, profession and zoning and bylaw system. But let's facilitate integrated demand side and supply side resource planning. That's principle number 1. Principle number 2 is to focus on performance outcomes, and Rosie's going to talk more about this, that foster competition and enable innovation. Keep the government out of defining the solution and let the market find the optimum pathway. And as Robert said, regional markets will have different solutions, whether it's for hydrogen or energy efficiency or building design. Allocate responsibility to jurisdictions and institutions so they're not tripping over, kind of shared responsibility, or so that there's ambiguity on who is ultimately responsible for achieving certain levels of market transformation. Number 4, leverage life cycle investment triggers. Let's piggyback decarbonization and resilience on existing investment triggers, such as end of life of your roof, your glazing, your balconies, your boiler, your air conditioning system. And let's bring these new objectives around resilience and decarbonization into those investments, rather than trying to achieve decarbonization and resilience with investments that are separate from the normal life cycle capital asset management and replacement. And then finally, data-driven, outcome-based policymaking, which I'll speak about a little bit more. I'm aware of my time, so I'm going to just quickly show that these are all the regulatory institutional frameworks that exist for building. Look how many we have in Canada. So we've got land use planning, we've got the building code for new construction, we've got separate regulations defining energy efficiency standards for equipment, we've got mandatory depreciation reports for homeowner associations or strata corporations on how they do their capital planning. We've got different standards and tax exemptions and building codes for building renewal. If you happen to be a purpose-built rental building owner and manager, over on the far right there, you have something called rent control. So you cannot pass through the cost of building renewal to your tenants. There are some limited things that you can do and receive compensation for that. We've got real estate related regulations, and then the bottom 3 are energy supply. So right now the whole industry is regulated by these horizontal silos. Okay, these are all happening separately, and there's separate institutions that are driving these regulations, these standards, these market transformation measures. So our proposal is to flip it 90 degrees and plan for the customers, plan for the clients, plan around the residential single-family dwelling building stock, the commercial building stock, commercial real estate, the public sector building stock, institutional, the purpose-built rental, the social housing, and bridge between those institutional silos. So that's the principle. Read our paper for more details. Now, focusing on performance outcomes that foster competition, establish common performance standards like tiered energy codes. Here in BC, we have something called the Energy Step Code, which is wildly successful. Probably 80% of new construction of residential housing is under the Energy Step Code, and it has 5 steps. And the federal government, Codes Canada, has borrowed that approach in the National Building Code. Empower professionals to design to higher level standards, harmonize regulatory frameworks, maximize flexibility, establish an innovation ecosystem. The CAE president, Sohei Agas, I'm not going to pronounce his last name right. Robert, in our Q&A, you can mention his name. He has championed this notion of an innovation ecosystem for the upstream oil and gas, and we should replicate that for the building sector. Develop adaptive design solutions that in the future can adapt to photovoltaics, for example. Focus on risk identification, vulnerability assessment, and mitigation. So that's the role of the engineer. And finally, communicate. Engineers, we need to communicate. We need to communicate the risks to government policymakers and the mitigation measures. the solutions. So I've talked about the life cycle investment triggers. So there's a trigger when you build a new building. It's called the building code, the building bylaw for your local municipality, the electrical code, the planning and the zoning by the local government. So let's piggyback resilience onto that one. The next stage, the next trigger in the life cycle of the building is the building recommissioning or continuous optimization. That should occur about every 3 to 5 years. It's regulated in some jurisdictions in the US. It will come to Canada. The next stage of regulation is when your windows or your boiler comes to end of life, a regulation applies to what boiler or window you replace it with. And then finally, there's the 30-year capital asset management plan for your building, and certain regulations come into play. So the advice is put our objectives into those existing regulatory frameworks. And then finally, this is a good segue into Rosie's presentation, which is to facilitate data-driven, outcome-based policymaking. Wouldn't it be great if the National Building Code of Canada could be based 100% on data, measured data on the performance of buildings? And I saw there was a question here from Richard Fletcher. Is there any effort to follow actual energy use in buildings registered as energy efficient? And the answer is absolutely yes. It's happening in the US. It's called Building Performance Standards. The state of Washington has regulated it for commercial buildings. The city of Vancouver is next year has its first measured energy performance reporting deadline. And wouldn't it be great if 5 years from now, the building code is simply set at the 50th percentile of how all buildings are performing. So the code becomes automatic. It's like a ratcheting thing. So, the building stock gets better. You've got a bell curve, and the code is set at the 50 or the 60 or the 70th percentile, so that the next stage of buildings will get even better. They'll only be built to the best of the building stock that's already in place. So that concludes my presentation, and I do have a question for discussion, which what is the appropriate role for local governments in this effort? Or if you have other questions, back to Robert.
Andrew, I would like to just point out that the process for asking questions is also a process for providing answers. So if somebody wants to address particularly Andrew's question about municipalities, please do that. And Andreas, because you're on the panel, you can actually ask a question out loud, so to speak. So please go ahead.
Okay, I'll be very quick because I have to leave for another meeting on this big grant we got for resilient and decarbonized communities. So I totally agree with Chris and Andrew about the need to do resilience and decarbonization together. And that's where municipalities are very important. They're the critical player because they have to face the ice storms and the floods and everything. So municipalities are very critical, and I was very pleased with the excellent presentation of Chris and Andrew. We are a very good team together, I think. And so one thing we want to do is get further input from everybody now that we are finalizing the roadmap report. Send your input to Andrew, Chris, myself, Robert, and that's all I have to say. Sorry, I have to leave for another meeting now. And it was a pleasure to do this event with a distinguished panel. Okay, bye everyone.
Thank you, Andreas. And just while I'm sort of have the floor here, Sohail Askapur is the president of the Canadian Academy of Engineering. Very, very involved in the energy sector, very involved in methane abatement within the energy sector. And I know he joined Andrew at the Pacific Northwest Summit, and this is such an important area for so many groups of people. Just looking here at the questions, so Heather is asking about consistency for builders, and I think this is a very, as was clear, Andrew, from your chart, the energy sector itself gets regulated heavily, but there are relatively few players, and they're large. The transportation sector gets regulated, but again, relatively speaking, the number of vehicle manufacturers and stuff is small, so the regulations can focus on sort of a limited number of cases. And even for industry, the number of really big industries that we have, steel, cement, other big manufacturing and chemical industries, is still countable. But this idea of every builder in every municipality of every size across the country almost seems intractable in terms of its complexity and the different constraints and motivations available to every builder. So maybe you could just say a few words about the complexity of this problem and how you actually get everybody, all the cats headed in a single direction.
Yeah, that's great. I'm happy to answer Heather's question. So I think the most important thing that's happened for decarbonization in Canada was actually the Supreme Court decision about the challenge on the jurisdiction of the federal government to set a price on carbon. And really it was after that point that we achieved the tipping point, and we're going down the other side of the curve. We're accelerating very quickly. And so the fact that the federal government has jurisdiction to set a price on carbon means that by extension, the National Building Code of Canada will, they're exploring the policy options to set a standard, if you will, for carbon. And in fact, there's an open call for comment right now as we speak from Codes Canada to comment on a policy paper. So I think where we're going, what is the vision and the target needs to be set nationally. And I think how we measure performance needs to be standardized so that we're not talking about, 3 different measurement protocols, as we've seen with, even building energy efficiency. Like, does this include the garage, the parking garage of the building in the square footage or not? So we need that standardization. And we also need options and a roadmap. I call it a technical roadmap of, between now and 2050, we need to be at -80 or -100 emissions. And that, I believe, is legislated nationally now. It has been legislated in BC for a number of years, but allows some flexibility for innovation and cost competitiveness, so that each region and each building designer and each builder has multiple pathways they can choose to get to that ultimate target. But I do think it's imperative that everybody is going to the same destination. So I don't know if that helps. Here in BC, we've committed to harmonizing with the National Building Code of Canada in our next edition of the BC Building Code, which will be 2027, I guess. Well, there will be a 2023, but the next one will be 2027. But there will be leeway within that to determine the pace of change. And I see there was a question about the pace of change. And that's the difference. We're all going to the same destination, but we have a different pace of change depending on the capacity of our jurisdiction to deliver. And those who are the early adopters are taking higher risk, but they might also have bigger rewards in various forms by moving out front. I also wanted to answer Paul Accione's question about district energy. And in fact, hot water is also a zero carbon fuel. It is also, you can use hot water without producing greenhouse gas emissions. So, you know, electricity, hydrogen, hot water are three energy currencies that have zero scope 1 emissions. And I do invite Chris Kennedy, if you have any feedback on district energy. But here in Vancouver, we have multiple district energy systems. One's actually based on steam. Another one is based on hot water, or several are on hot water. There's one at Simon Fraser University that's owned by CorX, which is a public utility that provides hot water that is almost 100% renewable energy derived. And so that is definitely a solution. And again, the choice of fuel is a competitive marketplace.
Ken, thank you for that. Chris, did you want to add a couple of words, or shall we move on to Rosie and the final presentation?
Let's move on to Rosie.
Okay. Rosie, please take the floor, and you get to bat cleanup.
Thanks, Robert. And thank you to the preceding speakers. I just have to tell you, there are roofers working above me, so you may hear some background noise, or you might see me jump when something big gets dropped. It's been a great pleasure to work with this group over these years. My day job is in kind of a more general area, so I don't think about buildings all the time, but being able to dive into buildings at our different junctures along this project has been really interesting. It was also interesting to hear both Robert and Chris talk about learning about energy from living in England. I lived in England, I was raised in Winnipeg, but I lived in England in the early 70s, and there was an energy crisis and lights went out. And to a 12-year-old from Winnipeg, that was really impressive. It changed my career direction. So we heard Andrew talk about needing evidence-based and measurable goals. And so that's what I'll talk about first, and then I'll go on to talk about empowering engineers. When we're measuring progress, as we know, the goal for buildings related emissions is net zero by 2050. We will be asking ourselves over the coming years, are we making progress? So we're going to need some metrics to reassure ourselves, hopefully. And what are the characteristics of those metrics? We need something that thousands of practitioners across Canada can measure and maintain data on, metrics that'll be valid across regions and across sectors of the building industry, metrics that are acceptable to the stakeholders of the building industry, and they need to be scientific, not political. So those are guidelines as we were looking at what can we identify as metrics. We need to be collecting data on performance. That's a high priority. That will verify the building sector's transition toward the vision that you've heard today, and it will also help to inform future government policy. Okay. So 4 groups of metrics: net zero emissions, increase in energy-related resilience, changing the design process, and improving building energy codes. Okay. Starting with the approaching net zero emissions, we want to look at what is the fraction of new buildings and major retrofits that are using the full potential of energy efficiency, energy storage, renewable energy, and also providing adequate electric vehicle charging capacity. What's the fraction of new buildings and major retrofits that are doing that? Then what is the fraction of operating energy for buildings in Canada under normal conditions, not talking about disrupted conditions here? What's the fraction that's supplied by site renewable energy or regional renewable energy? And then what is the fraction of smart buildings that are connected interactively to smart grids? Looking at grid decarbonization in coordination with built environment decarbonization, what is the fraction of grid energy delivered to Canada's consumers through utilities that have confirmed decarbonization commitment? So those are the net zero emissions metrics. Okay. For metrics related to increasing energy-related resilience, we're looking to move toward buildings that are designed for predictable resilience at site and community scale. So what is the fraction of new buildings that are designed to be resilient? Initially, buildings that are designed to generate their power and heat for a certain period. So under the event of disruption. And then at present, buildings, as we experience it, can have an unpredictable response to disruption, but we can address that now that we have pretty advanced skills in modeling. We can actually test a building's response to disruption, for example, disruption in the electrical grid, and that is going to be helpful in planning for disasters or difficulties. So what's the fraction? This is a metric we'll want to track. What's the fraction of new buildings that have a predictable response to disruption? That's at the building scale, but we also want to look at the urban, the community scale. So the metric would be, if you do the urban modeling, what's Canada's urban population living in communities with reliable, verified urban modeling? What's that fraction? We want to increase that to 100% eventually. Metrics related to changing the design process. We're trying to move toward building design and evaluation processes that support accountability and continuous improvement in a changing climate. So we need certain people with certain skills to do this kind of design. So for example, credentialed subdisciplines like building energy modeler or energy modeler, people with skills related to air tightness and envelope and comfort. For a metric, what's the fraction of positions like that are filled within 1 month of advertising? And then looking at new buildings that are designed with modeling and simulation software as a design tool. This is distinct from buildings where energy modeling is used to prove compliance with a prescriptive code. We want to think about using energy modeling at an early stage, the earliest possible stage of building design, so that it actually helps to shape the building as a highly efficient building. So what's the fraction of new buildings where energy modeling is used as a design tool? Looking beyond the beginning of occupancy for the building, we can take the design energy modeling that's used in design and calibrate it with actual use conditions and with actual weather conditions. That helps us use it to further predict the building's performance going into the future. So a metric for this would be, what's the fraction of 3-year-old buildings that have building information modeling based calibrated model? The last two items here are about fragmentation. There can be fragmentation in the way a building is designed, constructed, commissioned, and operated. To reduce fragmentation and siloing of those different parts of a building's life, a building needs a technical continuity strategy in place. And a metric for this would be, what's the fraction of new buildings that have a technical continuity strategy in place? Similarly, there can be fragmentation in how budgets are applied. So we're looking for a metric being a fraction. What's the fraction of new buildings that have an integrated budget strategy such that energy conservation measures can be paid for out of the capital budget and not have to wait to pay for energy out of the operating budget? Okay. And lastly, a set of metrics about improving building energy codes, looking toward building code strategies that are going to support near and long-term goals. The net zero definition needs to be clarified and needs to achieve a level of acceptance by the construction community and the utility community. The fraction of new floor space that's governed by building codes that use an ultimate goal as a reference is significant. And an ultimate goal, for example, would be net zero rather than being like 25% better than such and such a code. You want an ultimate goal. The fraction of new buildings that receive performance-based code approval will rely on buildings that are modeled and can be proven in advance of being occupied to actually meet performance-based codes. So we want to know what's that fraction of new buildings. And finally, code policy will need to be reviewed and updated throughout levels of government and jurisdictions, and we'll look for progress in how that activity is progressed. Okay. So that was about metrics, and to talk for a minute about empowering engineers. An expanded role is needed for engineers in this area because the profession serves multiple business sector stakeholders. It bridges across government, institutional, and sectoral silos. And engineers align with codes of ethics, including hold paramount the safety, health, and welfare of the public, including the protection of the environment. Engineers are in a unique position to catalyze meaningful action on policy goals while highlighting limitations of design solutions in the context of management practices, local context, and a changing climate. Okay. So here's a call to action for engineers. Through our report, we invite engineers to establish a vision for future-proofing buildings, and engineers as individuals to evaluate risk factors and mitigation measures. For engineers who are involved in building operation, measure building performance and use that data in concert with building owners to optimize operation, and also bring that data forward to contribute to policy development, including development of codes. Collaborate with academia on demonstration projects, as we've heard about, and collaborate with the Canadian Academy of Engineering on an innovation ecosystem that can help us find new design strategies and new business models. Okay. What's in it for engineers to have this broader scope for building design engineers? We can serve clients better and strengthen competition. We can move toward more harmonized system of codes. We can elevate building design and focus on stewardship, address the gap between practice and research, attract recruits who are motivated to improve buildings, engage with design professionals and engineers in other fields who can bring data that may help us solve big picture problems. And overall, we can participate strategically in climate action. Happy to answer any questions.
Maybe I'll leave Rosie's call to action up, that can, if you have any comments or questions.
Hey, Rosie, thank you so much for that. That Andreas isn't here, so I'll make a point or ask a question that I'm sure he would if he was, but to do with just the engineering and design of buildings. Andreas has pointed out that doing and this isn't my area of engineering, but actually doing a detailed thermal design of buildings just to understand how you're losing the energy and how you're gaining the energy and the rest is still not part of a lot of building design, as I understand it. And so given the biggest energy consumption here tends to be around heating and cooling, do you think that there are gains to be made in doing a more thorough thermal design of buildings?
I think that's what we're talking about when we talk about energy modeling of buildings. The more that designers understand exactly how those energy flows are working, the better job they can do on creating buildings that are innovative and that are guided more by energy considerations than possibly other pressures or factors. But I would welcome others on the team to address that question too, Robert.
Yeah, and I think just to be a sort of a little clearer, some energy modeling is kind of input-output models, and I think the things that we were discussing, or I was discussing with Andreas, was more like different approaches to designing balconies and how they look like heat fins sticking off the side, and what was the wind flow around that building. So, the same kind of, if you were treating a heat exchanger or a pressure vessel or something, you go at it in a different approach than if you're designing an apartment building. And maybe there's some of those approaches need to be brought into the building sector.
I think there are a lot of pressures on how a building is going to look, and that's going to affect what the exterior is like. And Andrew can speak to this more, but I think in a place, for example, like Vancouver, where views are really important, it's hard to get away from having big window walls, but they're not very energy conservative.
True enough. Okay, so Marilyn's got a couple of comments here. One of them is around the NRCan invitation to professionals to participate on how professionals learn and use climate change adaptation knowledge and skills in their practice. I think that would be a great idea if everybody could go in and participate in that. Yeah, and you know, how not just the engineers, but everybody involved in the building process, where they stand in terms of learning and applying climate change adaptation. So I don't know if, I think it's a great idea. I don't know if anybody's got additional comments around that, but you know, are all of the stakeholders within the building community on the same page when it comes to climate change? Would be one of my questions.
So I could comment briefly on future proofing, and I invite others to comment, Rosie, for example. But as people know, the building code is based on historic climate data, and it's also based, you know, the standards that we apply for windows, for example. You know, what is the wind, water, and thermal resistance of windows is based on, you know, a particular weather station within a particular municipality. And there was an interesting situation at one point in Burnaby, British Columbia, where the enforcement of the building code was based on the weather station on the top of Burnaby Mountain, where Simon Fraser University is. And it was actually in a different climate zone than the bottom of the mountain. So the bottom of the mountain would have put it in the Seattle climate zone, or you know, the Delta climate zone. But on the top of the mountain, it put it in the same climate zone as Kamloops. So I think there's a fair amount of leeway there for engineers. And, you know, if presenting a position that we should go with the more conservative, in other words, the precautionary principle of an extreme heat event or extreme precipitation or extreme wind, then to sell that to the client on the basis of risk management and you know, possibly enhancing the value of the building, you know, for sale, you know, to be able to say with a small r, this is a resilient building. So even if the building code isn't being enforced to that more conservative standard, to actually upsell the building and you know, from a resilient standpoint. Similarly with seismic and earthquake, there's an argument for going beyond life safety standards. In other words, the building is not going to collapse in the design earthquake, or you're not going to die in the design earthquake, to a resilient standard whereby the building will continue to operate after the earthquake. And you know, the cost estimates, you know, range from between 1% and 2% incremental capital cost to make that earthquake proof building resilient so that it continues to operate after the earthquake. Thank you.
Andrew, some great thoughts there. I do notice that we have reached the end of our time here, and I know people will be under certain pressure to leave. I would invite our panelists to just give perhaps a last thought or summary, and might start with Chris on this. Chris, do you have any?
Oh, I'm not sure I have any great comments at this point, other than really just welcome more feedback on the roadmap. I think it still needs a fair amount of input and polish. So looking forward to seeing people's comments on it.
Yeah, excellent. Rosie?
Yeah, interesting to see in the Q&A that there was a comment, you know, who really is in control here? The building owners are controlling what the engineers do. And that's the kind of realistic commentary that's going to be very helpful to us in improving these metrics that we've idealized. Thanks, Robert.
I just want to make one quick comment, and then I'll give the final word to Andrew. You can see on the screen the next steps. In one of the things that's been interesting working on this project is a lot of the leadership that's been shown by the province of British Columbia on this. And I think sharing the various experiments that are happening across the country, even getting a little rivalry between premiers on how they're making progress would be very interesting. And understanding that climate issues, weather issues, earthquake issues are very different in a country this size, not just province to province, but within provinces. And I know, even if you just take the big municipalities and see how they're comparing. But Andrew touched on a point which I think is extremely important, which is not just in buildings, but in an awful lot of our codes. It is all based on historical data. Here in Ottawa, we've got high water levels again, and everybody's saying, well, 2017, 2019, we had once in 100 year water levels, and it looks like we're going to have once in 100 year water levels again in 2023. So it sort of challenges a little bit what 100 years is. So I think this idea that we start having to switch from historical data to modeled forward-looking data is going to be a huge leap of faith across. A lot of work is going to need to be done by the climate scientists to make sure that those numbers are acceptable. And I think there's going to have to be a very big debate as we decide how to understand that future climate modeling. So I look forward to people's comments on that. Andrew, I will let you take it out, and I'm just thinking, how do we get people? How should people get back to us who have additional comments or questions?
Great. Yeah, thank you, Robert and Rosie and Chris. So I invite all of you to join us in Victoria in June of 2023, next month, for another version of this presentation, another version of this conversation with industry practitioners. So as opposed to the authors. And the other thing is I invite all of you to meet with your MLA, MPP, and MP. And if you wish, your local government councillor who's most interested in buildings, to talk about future-proofing buildings. We do need to socialize this. Engineers are in a great position, as Rosie noted, to bridge all the silos. Engineers are involved with all the silos, and to sit down and just provide your perspective on the topic. And this paper, which is 50, 60 pages, will be posted on our website in a draft form next month. So we'll continue to receive comments until the draft is removed. It's penultimate draft, and you can take that in your back pocket as a reference. So that's my main message, is meet with your policymakers. And I think I'll pass it back to you, Robert.
Thank you.
To close.
Yeah, so Andrew, that's great. So as you noted, everything will be posted to the website. If you just Google Canadian Academy of Engineering or CAE-acg.ca, we'll get you to the website. And in fact, I think you can get to admin from the bottom of that website through the contact space as well. So
yeah, and sorry, I should have added, we will email the PowerPoint to everybody who's registered for this webinar. So that's excellent. Another channel to provide your further feedback. And Richard Fletcher, thank you for your final comment here. Talk to politicos and one pager of what's the value to them. We will make sure the executive summary is something that you can hand to your politicos, your elected officials, as a take home for them.
Thank you so much. Okay, and with that, wish everybody well.
Bye-bye. Take care.
Bye-bye.